Hey guys, what's up? I'm gonna be out tomorrow, so I figured I'd teach you about a couple of special cases as far as quadratics go, and polynomials in general. But just want to show you a couple things real quick, and you could probably figure these out without knowing that they're special cases. But I figured I'd show you anyway. So take a look at this real quick. Let's say I said x squared minus 25, right? I got a quadratic there, right? So if we try to solve this, if we set it equal to 0, right, we could find two zeros, right? You might say, well, hey, that looks kind of weird. Doesn't look like there's a b value, right? So a would be 1 and c would be negative 25, right? But what's b? Well, b would be nothing, right? So if you think about this in the strict sense, you could kind of look at it like that, right? And if you're trying to factor, you might say, okay, well, what are factors of negative 25 that add up to nothing, right? What are factors of negative 25 that add up to nothing? Well, if you think about it, factors of negative 25 that add to nothing would be positive 5 and negative 5, almost like conjugates, right? So you could factor it like this, x plus 5, x minus 5, right? And x plus 5, x minus 5, that would be the factorization, and the two zeros would be 5 and negative 5, right? Well, there's a special name for this, okay? There's a special name for this when basically you have something being squared here and something being squared here with a minus in the middle. It's called a difference of squares, okay? And the way, let me get an eraser real quick, I'm sorry. The way a difference of squares works is basically, if you have something being squared here and something being squared here, you essentially are going to write two kind of binomials, right? Whatever the square root of this one is, which is x, you write here. And whatever the square root of this one is, which is 5, you write here. And then you just do 1 plus 1 minus, just like those conjugates we learned about, okay? So it's a pretty easy formula. And basically the way it works is if you have a squared minus b squared like that, a squared minus b squared, the formula goes like this. A plus b times a minus b. Okay, that's the formula. That's the difference of squares, okay? So for example, I mean, if you had like 100b squared minus 16, well, hold on. I'll do 100b squared minus 49, something like that. And you said, oh, that looks complicated. That looks like it might be hard to factor and find the zeros. Well, it's not very hard. This happens to be a perfect square. This happens to be a perfect square, and there's a minus in the middle, right? So all you'd have to do is say, okay, well, there's going to be 1 plus and 1 minus, right? 1 plus and 1 minus. You might say, well, what's being squared here, right? Well, 10 squared is 100, and b squared is b squared, right? So basically the thing being squared here is a 10b, right? So if you did a 10b here and a 10b here, right? 10b and 10b, and here you have a 7. Well, guess what? You just factored a difference of squares. It's 10b plus 7 and 10b minus 7. You could easily find the zeros by setting both those equal to 0 if you wanted to. Okay, so that's all a difference of squares is. It's just you know, something being squared, something being squared with a minus in the middle. They call it a difference of squares. Okay, so this kind of pertains more to algebra 2 and kind of what we've been learning about. But look at this real quick. Let's say I said x squared plus 4. And I said, okay, I want you to factor that and find the zeros of it, okay? Well, you might say, well, wait a minute, you just said it needs to be a minus in the middle, therefore I can't do that. Well, we could technically think about this like this, right? Okay. And now it is a difference, right? Now you might say, okay, well, I know it's being squared here, right? You could easily take the square root of that and say, okay, that's going to be x, right? But what about this over here? Well, what's the square root of negative 4? Square root of negative 4 would be 2i, right? 2i. So actually, you could say, watch this, you could say x plus 2i, and x minus 2i, like that. And that way, you can actually factor this when you treat it like a difference of squares, right? What's being squared here? X. What's being squared here? 2i, if you took the square root of it, because 2i times 2i is 4i squared, which is, in fact, negative 4. So if you ever get something with a plus in the middle like that, you can treat it like this and actually break it apart with imaginary numbers. Now, if you look at this right here, at this bottom part right here, and said, what would the zeros be? Well, they would be 2i and negative 2i, right? So that means that this quadratic here, this x squared plus 4, if you graphed it, it would never cross the x-axis, right? Because the two zeros are actually imaginary. So, long story short, whenever you have a squared minus b squared like that, you can always factor it as a plus b times a minus b, okay? That's called a difference of squares, okay? Very simple to do, okay? Now, let me show you one more special case here, okay? Now this obviously is not a difference of squares, right? We have an a, a b, and a c, right? 1, 8, and 16. And if I said factor this, you might say, okay, well, what are factors of 16 that add to 8, right? 16 that add to 8. So let's think for a minute. What are factors of 16 that add to 8? If you said 4 and 4, you'd be right, okay? So the way we would factor this is we'd say, okay, well, x plus 4 times x plus 4, like this. Okay? And you could even, if you wanted to, you could say x plus 4 squared, right? Okay? There's a special name for that. This is called a perfect square trinomial. You might want to write that down. Perfect square 1, 2, 3 trinomial. Okay? You can probably guess why we call it a perfect square trinomial is because you're squaring this to get this, right? So the fact that you're squaring that binomial to get that, that's why we call it a perfect square trinomial, okay? And if you can ever spot a perfect square trinomial, it's pretty easy to do. Look, you notice what's being squared here is an x, and what's being squared here is a 4, right? So you could actually do this. You could say, okay, an x is being squared here, right? A 4 is being squared here, so I could put a 4 and a 4. And since there's a plus in the middle, you could just do like this. But you could easily figure that out with the skills that we have. But there's a special name for it. It's called a perfect square trinomial, okay? So let me show you one more of these perfect square trinomials. Let's see. This will relate to what we did a minute ago or a day or two ago. See this right here? Okay, we can factor this. No big deal. Remember when a is not 1, you say 4 times 9 is 36, right? And you say, okay, what are factors of 36 that add to negative 12? Well, factors of positive 36 that add to negative 12 would be, think about it, factors of 36 that add to negative 12. If you guessed negative 6 and negative 6, you got it right, okay? Well, let's do this the old-fashioned way, watch. If I split this into negative 6x, right? Split that up. Drop the 9, drop the 4x squared, right? Just like that. Factor by grouping, right? What comes out of the first two? 2x, that's correct, and you're left with 2x minus 3. And if you look, what comes out of the next two, you could take out a 3 or a negative 3, but I would take out, if you take out a negative 3, you're left with 2x minus 3 as well. And what I want you to notice is this, look. Those are 2x minus 3, right? So I write 2x minus 3. Those are 2x minus 3, so I write another 2x minus 3. And what you notice is that 2x minus 3 happens twice, right? So you could write 2x minus 3 squared, and you notice that this is, in fact, a perfect square trinomial, right? If you look at the zeros, they're both 3 halves, right? If you added the 3 divided by 2, they're both 3 halves. So 3 halves actually happen twice. And if you remember, that's one of those they kind of bounce off the x-axis because it happens twice, right? But yeah, that's also a perfect square trinomial. Now, if you looked at this, look at that answer, right? 2x minus 3 squared, right? Here's another way you can think about this. If you notice this is a perfect square trinomial, and you take the time to kind of see what this look like, what's being squared here, right? Well, what's being squared there is a 2x. So you have 2x right here, right? What's being squared here? 3, right? So I put a 3. And since there's a minus in the middle, you just drop 2 minuses like that, and you can factor it like that as well. But we have the tools to factor it. It's just got a special fancy name. It's called a perfect square trinomial because it's a perfect square of that binomial that makes a trinomial. Okay, so that's another one. So difference of squares and perfect square trinomial, two special cases that you might want to take the time to get familiar with. Okay, so saying that, you got a little worksheet today to kind of look at some of those, but you kind of have the skills to do that already. It's just recognizing those will probably benefit you in the future. Okay, so make sure you guys behave. I'll see you guys on Tuesday, and don't do anything I wouldn't do. All right, y'all take it easy.